Hello, this is our group conformed by Jose Navarro, Jessica Bogota, Camilo Silva, and me, Sofia Morales, and these are the requirements to a solution to a problem. So in first place, the functional requirements are that the hardware must consider proper storage and transportation to avoid contamination and unwanted others during the handling process, taking into account the laws that support the care of the environment. The hardware must generate fertilizer from the organic waste that enters the facility, as well as allow the extraction of greywater. The monitoring system must have instruments to monitor and evaluate the performance of the waste processors designed by the PN1 engineering, including a graphic interface, and the machine must be capable of processing 20 kilograms of cardboard, wood products, garden material, and everything known as organic waste. Secondly, we must take into account the non-functional requirements. In first place, the system must guarantee the security of the employees in charge of waste management through the implementation of safety and accident prevention measures. In addition, it must fulfill environmental regulations. Secondly, the hardware and monitoring system must be reliable and available at all times. These to ensure proper waste management, including preventive maintenance. In third place, the system must be scalable, referring to the fact of being capable of adapting to the needs of the company, including the capacity to handle an increase in the amount of waste generated. In fourth place, the system must be easy to use and comprehend by the client to guarantee an optimal use. In fifth place, the hardware and monitoring system must be efficient in the resource management to minimize cost and the environmental impact generated by the waste management. Furthermore, being capable of generating a sustainable economy. In sixth place, the use of Power BI as a strategic choice based on the capabilities of data visualization. And lastly, the machine must be a visual representation which illustrates a possible solution to the client, and it facilitates its visualization. Finally, the legal requirements. We are going to explain the law and the requirement needed. So in first place, the law 142 of 1994, which equal cleaning companies are responsible for guaranteeing the adequate transportation of organic waste generated by the company. Then the law 430 of 1998, which its main focus is integral solid waste management plans, whose objective is the adequate final disposal. Then it's the Decree 2104 of 1983, which established the order to use public sewage system, when prior permission must be granted by the entity of charge. Then we found the Law 9 of 1979, which prohibits the use of contaminated water for irrigation of vegetable fruits when its consumption may cause adverse health effects, and this decree was taken into account in the creation of the hardware. Then the Decree 4741 of 2005, which established that solid and hazardous waste must be treated before reaching the sanitary landfills and composting plants. These must be located in a suitable area and comply with a minimum distance. And likewise, the plant must be designed by environmental regulations, and it must be constructed in a way that minimizes environmental and sanitary. We found the Decree 1140 of 2003. The presentation of waste must avoid obstruction, pedestrian or vehicular traffic in order to facilitate collection of the cleaning personnel. Then we found the Regulatory Decree 2462 of 1989. The hospital waste treatment and disposal plant must have monitoring systems to generate a circular economy. And in last place, the Decree 838 of 2005 We found that the user must separate harmful and harmless waste in order to minimize the spread of hazardous waste.
Entering to see the part of the analysis as subjects and their topics, we can tell you that the subjects that they used were linear algebra, calculus, static, and tool-wall Power BI. We must note that within engineering, linear algebra provides the ability to solve count problems, wins the professionalism, the logical and mathematical tools necessary to develop alternative solutions to the end of the daily challenge of their professional activity, such as the development of circuits, problems related to transportation and routes, as well as cryptography and encryptions, where the layers are considered vital elements in computer security. Traditional topics such as the calculation of event values and eigenvectors have found application in problems as diverse computer vision of the classification of sites of New York, but New York algorithms are others in response to needs specific application, and this makes it necessary in return of the circumstance they find themselves. One of the eras of scientific and technological development in which mathematical has been particularly used is in fields of computer science called of artificial enhancements, and specifically in its now machine learning. One the definition of machine learning says the base of skill. It's about programmation, computer optimize or performance creatings use these example or paths experts. Sophisticated techniques have been developed to build linear learning machines that have been sequential in many applications. And among the various problems of machine learning, and of the most important is in test classification problems. Linear algebra is used to describe the parameters with an structure of different algorithms. It is a toolbook on mathematics, tool of the use technique for manipulation groups and numbers in maths. It provides structures such as vector and matrix to hold math number, and new rules on how to add, subtract, multiply in divide terms. Because of all, it's essential for any machine learning professional developed and foundation of linear algebra. So in the mindset that was employed in audit, Cytics was used for the use of technology to and Power BI for data visualization.
For the hardware, it's necessary to take into account its operation, in which two types of operation are taken into account. In principle, it generates compost. You enter the 20 kilograms in the hopper, then the waste is crushed and divide what is useful and what is not. What is useful as compost is cleaned and moved to the back of the machine to be removed by a specialist person. The second process is focused on the biggest parts of the model, where the unused part is fed by some chemicals, which is then crushed again in the part that remain as an exist and is cleaned by these chemicals. This is transported through tubes and comes out through the extractor, which is represented by an orange valve, where the specialist person enters a hose to extract this water. In the software part, we find an interface designed with the purpose of remotely monitoring the system events and every necessary data. Besides, the system seeks to be simple for the use of any person. Within the software, we can find different data, each one represent with a graph showing what was happening every hour that the machine was in use. In this case, it was turned on at 7 a.m. and turned off at 9 p.m. Talking about the data provided by the software, we found some data such as composting, gray water, kilowatts consumed, tank filling capacity. All these divided by each hour it was on. Another interesting issue is that based on some research, we found that the use of events by the machine was necessary to be more precise with what was happening. For example, when the filling tanks were close to full, the system warned the user that it was time to change it. Finally, from the software, it's possible to both turn off and turn on the machine. All this for the proper functioning of the system.
The prototype design was divided into 5 parts, starting with Jessica Bogota, who targeted the product requirements as the main points to be taken. Identification of customer needs, definition of acceptance criteria for software and hardware, subject analysis, and identify objective. Afterwards, we continue with the creation of the hardware and software of the project. This task was carried out by Jose Navarro and Camilo Silva. For the hardware, some key points were taken as analysis of composting machines, investigation of gray water extraction machines, evaluation of possible machines, design of the machine sketch, and for the software is software documentation, evaluation of composting and water extraction process, analysis of possible program for interface generation, and graphical interface execution. Finally, the approach studied for the use of products, surveys and implementation of the products was carried out by Sofia Morales, who established the following points: established user-friendly design, regulatory analysis to generate the machine, implement prototype, step name, video creation, validation of non-functional requirements, validation of laws, and validation of functional requirements. Stage. Different stages were carried out during the development of the project, such as the research stage of each of the process topics, such as the legal part, the software and hardware part, and one of the more important parts, which was the management of organic waste and all that it entailed. After having all the important information on each topic, it was necessary to make a association with all the members of the work in order to better understand how to carry out the creation of the machine along with its software for monitoring the system. In, in addition to making contribution and important ideas to be taken into account as the legal part and comply with each requirement established by law, but also comply with the request for the proper management of organic waste. And finally, that the system information is displayed properly for any user without losing the simplicity when using it. Task. In the part of the task and activity process, and each person was assigned a task, starting with Sofia Morales, the general manager of the project. She was responsible for directing the entire project and also to coordinate the tasks in order to bring a proper order. She was also responsible for all the legal part involved in the realization of the design. In order to comply with all laws stipulated, the code be taken into account. Moving on to Jessica, our environmental expert. She was assigned to do all the research on the correct handling of organic waste. In order to devise an efficient and correct way, as well as not wasting any waste at the time of setting up of machine. And finally, our engineer from the university, Camilo and Jose, carried out all the research about the technology to be used for the project, leaving Camilo with the software part and Jose with the hardware part. From the point that investigation different projects that proposed similar solution and extracted the most important of each one, such as the use of the for the hardware, the best option of components for the machine, and the most optimal ways to put it together among many other things. Our general manager organized different meetings to carry out the next phase and the following task were assigned. Jose and Sofia will be in charge of design to scale how the machine will look like, and finally Camilo and Jessica will be in charge of design a graphical interface for the remote monitoring of the system, where the different data will be displayed.